All right, well, we want to be respectful of everyone's time, so I'll kick things off with Guten Morgen, or good morning, that I probably butchered, but welcome to the Deeper API Security Test Coverage webinar. My name is Nicole Jones. I'm a marketing manager here, and with me today is our Chief Security Officer and co-founder, Scott Gerlach, and our VP of Product, Lauren Nagel, who will be telling you all about the incredible new functionality that we just released in our Deeper API Security Test Coverage. So we've got a really fun Oktoberfest-themed webinar. Oops, sorry. Should have done that earlier, but we have a really fun Oktoberfest-themed webinar in store for you today, and we're going to do a open Q&A at the end. So drop your questions into the Zoom Q&A and we'll run through those at the end. Lauren, you want to tell us what's on the agenda?
Sure. First, I apologize for my voice. I wish I could say that this was from having fun at Oktoberfest, but I got a cold from my preschooler, so I'm sure some of you can empathize with that. But please bear with me while I chat this morning with everybody. So what we want to cover is really everything about this new Deeper API security testing release that went out last week. But ahead of that, we want to cover some context around why application security is still behind, what is DAST, why is it important, and how do we make API security testing easier and modernize it to cover our modern applications, release processes, etc. And then we'll go through that different functionality we released yesterday. And Scott is going to give us an amazing Oktoberfest-themed demo.
I'm going to try.
All right. So, AppSec team, you're outnumbered. I'm sure we have a lot of AppSec engineers on here, as well as hopefully some developers. So, the most recent ratio that we've seen both in Forbes and also during the RSA keynote this past spring is that AppSec teams are right now 1 to 100 developers. So imagine you're in this giant Oktoberfest tent and you're the server and you've got this huge load of a lot of heavy beers and a whistle, and that's it. You've got to like get your way through all these people with your whistle and all your beer and get them their beer. And if you're only one person in this huge tent, you can't possibly keep up with all of that. So another option is, if you're pretending that all your Oktoberfest attendees are your developers, how can you teach them to go serve themselves? And that's what we're going to talk about today, is how can you actually help your developers self-serve and run their own security testing so you can scale, right? And you can make sure that all that code going out through our modern CI/CD processes and so quickly and rapidly is actually tested for security bugs.
Hey, Lauren.
Yeah.
I kind of think that ratio is a little high. Like 100 to 1 is a pretty well-staffed AppSec team. Also, we're well aware that the analogy or the simile here of like teaching all the Oktoberfest people how to get their own beer, maybe not a great idea. But I mean, you kind of get the point, right? We're trying to spread out who has access to application security stuff.
Yeah, maybe they should be able to get their own water.
Yeah, there you go. They should be able to get their own water.
The beer consumption, or their own pretzels or something. Good call. Yeah, we don't want everybody self-serving beer at Oktoberfest. So fun fact about me, I started my career as a QA engineer, and as an SDET, we were always taught that the earlier you found a bug, the cheaper it was to fix. So we tried to find bugs in specs. We tried to write automation. We tried to test in parallel with the code being written, because the earlier we found that bug, the faster and easier it was to fix it. If bugs actually shipped out, especially back in the day, I'm old, back in the days where things went out on CDs, it was a lot of work to send an update or recall that, and it was really expensive. So now as a PM, if bugs come back, even while we're in the development process, it's really disruptive. And the same is true for security bugs. So if a security bug is found during production, it costs double after releasing it than if you find it earlier, you're coding either during coding or during that integration testing. So when I'm trying to get features out, like this feature release we just had, I've got a launch date, I've got marketing working towards something, we've got customers waiting for features, and all of a sudden security runs a scan, the AppSec team runs a scan, security team runs a scan, finds these security issues that are live out of production. So they're P0, P1, throws them back over to the engineering team. The engineers may not have touched that code for a few months. The engineer who wrote the code may not even be there anymore. We now have to stop the work what we're doing on customer focused features and work on these security bugs. My engineers also may not be familiar with the tools that were used to find the bugs or the process that they need to follow to ensure that those bugs are logged as fixed. So it's really, really disruptive if security bugs are found during production. Actually, when I joined StackHawk, this is one of the reasons I joined, because as a PM, this was just so hard for me to have to stop everything to fix these security bugs. Obviously, you want to fix them, but if we can find those security bugs earlier, they're less disruptive and they're phenomenally cheaper to actually fix.
Yeah, I think the other thing that's interesting about that, Lauren, is as a security person, it's maybe equally as frustrating, right? We don't know about a thing that's about to launch. We hear about it after it's launched. We test it. We find all these problems, and then we spend an inordinate amount of time, which is not where our specialty and skill set and value to the business is, trying to convince a Lauren that we should fix this stuff and blow up the roadmap. And so on both sides, it's super inefficient to be able to do testing and finding problems in production, which is super interesting. And hopefully we can try fixing that by testing earlier in that, when we're looking at that bar chart, where it's 2 to 3 times or 3.5 times cheaper to find and fix those bugs. I feel like there should be a way to find and fix this tech debt earlier, Lauren. What do you got any ideas there?
Yeah, I completely agree with you. And like I said, I used to be an SDET. I used to write automation to find and fix bugs all the time throughout the process. And we can cover majority of test cases with automation. We can also have some manual testing to cover corner cases. But to write all of that for security testing, you're doubling your effort. It's, you have to write exhaustive tests. So how can we reliably find all these security issues without writing that as exhaustive test for your application, or relying on slow or manual testing that just can't possibly cover everything, right? We can do this though. We have systems in place.
I have an idea. We can do that with security tools, specifically security tools that are built for developers. So as everybody knows, application security testing isn't new. Security testing isn't new. The new part of this is developer-friendly security testing. So if you think about legacy tooling, legacy scanners, application security things, they're built to serve security teams. Now, that's important. Serving a security team is important so they can stay on top of application security posture, what things we need to be investing in, but they 9.99999 times out of 10, they're not the ones fixing code. So why are we leaving developers as the last person that knows about this? So shifting this information over to the development team so that they can understand these problems that they've introduced or are creating or brought in a library that does the same thing, triage that and fix it is so important. So remove that back and forth, remove that 40-minute Lauren and Scott meeting where we're debating whether or not we should be fixing a security vulnerability in something that's been released already, and just cut that whole meeting out. Totally give the information to the developers so that they can test while they're writing code, understand those vulnerabilities, and triage, fix them before they commit code, before they push that to production. That should be the way that that application security should be working, so that we can move all that testing further to the left or earlier in the process, because it's cheaper.
Yeah. And, Scott already mentioned this, but we have, like I said, we have systems in place for everything else the developers do, right? If they have a syntax error, it won't compile. If there's a merge error, they get an error when they try to merge the code. If everything compiles and merges, but there's still other issues, that are behavioral or things along those lines. They run unit tests, they run regression tests, they have end-to-end testing that runs throughout their build process. And so they know before things go to production when there's bugs in their code. And there's all these different steps along the way where those are found. But we haven't figured this out yet for security testing, right? There's nothing right now. Well, there is, but most people don't have something right now that actually tells their security teams when they're about to launch a security vulnerability until StackHawk came along.
Yeah. So I think so today we're going to level set a little bit, right? We're talking about dynamic application security testing. There's a bunch of AST tools in the application security testing landscape. You've got SCA, which is software composition analysis, tells you about your libraries. SAST, which is static application security testing. DAST, those are the three big categories. DAST, which is dynamic application security testing. So why do we think DAST is important? Why do we think it's the thing that you should invest in first? That's a great question. I'm glad you asked. First of all, DAST really helps you prioritize your efforts, right? Most of those tools can generate a ton of alerts and a ton of like, hey, there's work to be done here, but they don't have the context of whether or not that work is important. So DAST is really awesome to be able to go, hey, this vulnerability is discoverable and likely exploitable. And looking at this kind of like a hacker would or a threat actor would, outside into the running application. Where should I be spending my time fixing application security problems? These things that are discoverable and exploitable are a really great place to start. And if it's not telling you about another problem, so in SCA and SAS land, you could get the same set of problems and a whole nother set. How do I focus down on what I should be working on? Testing a running application, as I mentioned. So StackHawk is a HTTP endpoint testing mechanism. If your code is running an HTTP endpoint, whether that is server-side HTTP, REST API, GraphQL API, SOAP API, we're happy to test all of that. And the best part is we don't care what language you built it in. So you can build stuff in Rust, you can build stuff in Go, you can build stuff in Node, you can build stuff in Ruby. Don't build stuff in Ruby. Don't build production stuff in Ruby. Okay, like if you want to do it, you do it. But you know, eventually you're going to have to rewrite it. Sorry, minor Ruby tantrum. Build stuff in whatever language you're proficient in so that you can get features to market, but also test that running HTTP application. And then also being able to recreate these tests. So in this discoverability and exploitability realm, be able to go, here's how an attacker would exploit this particular thing so that development teams can fix and retest and validate that they've fixed. Now the knock on DAST, this is the old DAST, right? This is the knock on DAST. Really high cost to implement. Lots of teams, lots of support contracts, MSAs, all that good stuff. Takes a long time to roll out. There is configuration involved with DAST, but this is the benefit you get out of it. You get that discoverable, exploitable stuff with minor configuration. Scans a fraction of the application. So we tune DAST down to be able to run it against production servers so that we don't take out production, we don't delete things in production, we don't affect other real users of the system, which then subsequently turns it into these scans take forever. We scan a small bit. We can only do it once a month, once a quarter, maybe once a year. And then the worst part of all of this stuff is all of these vulnerabilities you have to ship to production to find them. So StackHawk took that and spun it around and said, cool, let's follow good DevOps principles here. We're going to use configuration as code. We're going to set the configuration in the repository of the application that we're testing so that every application developer that pulls down this code can run the same tests. Everyone has the same ability to run the same tests. We can rapidly scan HTML endpoints, HTTP endpoints, REST, SOAP, GraphQL, as we mentioned. API testing is our bread and butter here. Automate those tests in CI/CD and provide that information to development teams in their IDE. We're going to look at this in the demo. Ultimately, find, triage, and fix these issues before we commit code, before we push it to production. That's us moving that process back to the left where our finding and fixing is 2 to 3.5 times cheaper.
So why has API security testing been so difficult? Scott just mentioned a lot of the reasons, but really fundamentally, API testing, security testing hasn't shifted from server side to more modern applications built with APIs and JavaScript clients, or you have headless APIs and true machine-to-machine APIs. So we've got our little Geico cavemen here who are living in the modern world, but haven't quite evolved yet. And, it just doesn't fit, right? So we really need to start to evolve security testing to match modern applications and modern application development teams and their processes and their velocity of releases.
Yeah, that's a good point, Lauren. So usually at this point, we start talking about why APIs are hard to security test, and especially not only like JavaScript client APIs, but real headless APIs, machine-to-machine APIs that are just talking to each other. There's no front end to drive. And we start talking about this. We refer to this as the pants problem, but not today, my friends. Today we're Oktoberfest themed, so we're talking about die Hosenproblem. So in our imaginary company here, we've got Wir haben Hosen. They're a pants company, and they're the Leder in Hosen. Put that in your dad jokes channel at your local Slack. Here's an example of an API for a company that sells pants, right? We've got a couple of different APIs here that do list all of the Hosen, get the details about an individual Hosen. Okay, I'm going to just say pants because it's weird. All right. And then there's some admin functions in here too. One is make all the pants free. I don't know why we built that into our API, but we did. And then we've got update the pants image. So if somebody has a new picture, someone's got new product shots for our pants, we have the ability to upload those. Those are admin functions. But here's where that starts turning into a really big problem. We sell a lot of pants. Most tools that we use to scan these APIs and websites don't understand this and turn those kind of 5 simple API calls into hundreds and hundreds of calls, trying to drive front-end web browsers, understand all the endpoints. And basically what it's doing is just iterating through the database of pants, right? So it's going, I've got this lederhosen that has straps, and I've got this lederhosen that has Edelweiss. Edelweiss. I did it right this time. And then I second guessed myself. Boy, terrible. This pair of pants has a belt and no straps. It's all the same APIs. And what we're doing is trying to drive a web browser to understand all of this stuff. And it just takes forever and it's super inefficient. Also, the really bad part is wir haben so viel Hosen. It's like a lot of pants. And so all of this takes forever. It's just hundreds and hundreds of calls, which is what leads to part of the problem of why does the scan take so long? Because we're trying to drive the API very inefficiently. So what would be more effective is if we could take all of this pant information and take an individual pair of pants, right? So you look at that one REST API call that I have down here at the bottom, which is give me the details about a pant, about one of the pants. You have to be able to stick valid information in there to make that endpoint work. And that is what used to drive, I got to drive the web browser. Not anymore, my friends. Wow, that's terrible. So it's really important to be able to have valid information to stick into that route to drive that route correctly, as well as invalid information. So not only testing that pant ID variable for problems, but also putting valid data into that pant ID to be able to exercise that API correctly and get farther into the API. And that's some of the stuff that we launched. Lauren, tell them about some of the deeper security testing we launched.
So now getting into our release from last week, hopefully you all have read the blogs or you got the email about it, and that's why you are here listening to us yammer on this morning. So let's get into the functionality that was released last week. So custom test data, Scott started to talk a little bit about this, but you have those 5 APIs. You don't need to test them with every single pair of pants, but you maybe want to test them with some specific pants. So you can identify that specific pair of pants that you want to test them with and enter that data instead of either having random data or just the data that the Zap scanner, which is what we use, will input for, say, a string or an integer input value. You can now specify that. So if there is a specific pair of pants, in this case, we've got the belt, no suspenders, you can put that through all your endpoints. Also, as Scott was saying, maybe you want to test out with error data or data that's incorrect and make sure that doesn't open you up to some security vulnerability. So you could also put in wrong data like a dirndl or a dress in here instead of a pair of pants and make sure that doesn't blow up your API. But now all of this is under your control. You can come in here and configure. We also have a faker library. So if you don't want to write all of this test data yourself, you can use the faker library and it will create fake email addresses, credit card information, phone numbers, etc., with the correct format. So the format is correct so that if you are trying to do something and you put foo instead of foo@gmail.com, you don't get rejected because it's not in an email format. So all of that is now available to you. It is live out with the app. So please go test away with all your own custom test data. Next, custom scan discovery. So Scott mentioned that we have, we use open API specs, and that's what we've traditionally used with StackHawk and seen as the gold standard. But we know that a lot of people already have test tools, and they talked earlier about if you are writing those exhaustive security tests, if you have done that, if you have a QA team or you guys have already written tests, go ahead and use those to run your security testing. Why reconfigure 2 different tools? So we have first-class support now for Postman or Cypress. If you use either of those, we will use that test data if you have already configured it. So you don't have to configure that test data twice. If you have configured it for Postman or Cypress, we will pull that data in. And you can just use this custom command here in your config file, specify the path to the script, and we will run that script along with our scanner. Our scanner will follow along. And we will also still run our spider, or if you have seed paths, we will still hit those seed paths. So this is a very comprehensive way to scan your APIs and test them. We also have a Postman Docker image coming soon. So you'll be able to load up the Postman Docker in your CI/CD pipeline. And we have Selenium support on the roadmap. So if you use Selenium, which I know is a very popular tool, we have a lot of customers that use it, we'll also be adding this support with Selenium too. And last, but certainly not least, custom test scripts. So we know that every app is a little different, just like every Oktoberfest tent is a little different. Everybody's their own little snowflake, and everyone has their own unique test cases that they need covered. So now you can write those test cases yourself. In the blog, there is an example of how you can write a test case for tenancy checks. Maybe you have business logic, like that API admin function that makes all the pants free. Probably don't want that to actually go out to production and find a way for everybody to make all their pants free. And then you just have a big pants party. But you don't make any money, which is never any good. So we should probably throw a giant alert red flag if users can get to that part of the API. So you can now write test cases to cover business logic, cover tenancy checks, or if there's any vulnerability that's not included in the default StackHawk policy, you can actually add that in now to make sure that you don't ever have a certain vulnerability that gets you twice. So we're very excited about all of this functionality. Happy to answer any questions about it. Scott is going to show us what this all looks like live in a demo now.
That's right. I love everybody. Okay, so please ask questions in the Q&A. I love that people are liking the pants, that we're stepping into the pants analogy. That's an amazing pun all by itself. I love it. Here we go. Live demos. It's always the most fun part of my day. Okay, so here I've got an API running, and Nicole is going to put into the chat where this repository can be found. So if you want to mess around with this, I've published all this stuff to my own personal repository. Nicole will put that into the chat or in the Q&A or someplace where you can find it. And it'll be in the follow-up email that you'll probably get. We've got an application running here that has the ability to serve, you guessed it, pants. So in our pants application here, you can search for pants. It has the ability to do some other stuff. It also has some users in it. So this is actually running on my machine here. So you can see I can log into it and I can get in here and I can look for hosen and find hosen. Okay. That's all running in my machine. What I'm showing you here, actually, it's also an API. So over here in my Postman, I'm logging into this particular application and I'm looking for, let's see, I'm using a item search here and we can search for hosen and we have the best hosen. Yay. Pants API. Get it? Okay. There's also some users in here, so we can search for users too. So we can search for users and pull back. We have the best. Not only do we have the best pants, we also have the best users. So we've got users in here. Those users have a tenant ID attached to them. So lots of interesting stuff. And what I did was when I signed in, I just used the regular username user and the password to log in, get a bearer token. Then I'm using that bearer token across that API. Now we need to security test this. So this is what the StackHawk YAML, StackHawk configuration looks like. And as you can see, we stored that configuration in the GitHub repository so that everyone can test the same thing as they're building code. And in this particular one, you've got, where is this host running? Local host. So you saw that earlier. What environment name am I testing this is? I'm going to use custom tests for this one. And then my application ID. These 4 lines are the only lines you need to be able to run a scan. The rest of this configuration is all about how to make this scan work better for my application. So that's why we're looking at stuff like exclude the logout path. So we don't log the scanner out and it can continue running. There's an authentication section. So we saw authentication in our Postman collection. This is how you set it up in a StackHawk YAML. Just have to set it up once, commit that code, and everyone gets the same configuration. There's a couple important pieces that are in here too. So this is how we usually do open APIs. So REST APIs. We say, here's where the path to the open API spec is. In this particular example, it actually lives out here on a URL. Open API like that. There's the open API spec for this thing. But let's say that you only have the Postman collection and you want to resubmit this form. Let's say you only have that Postman collection. Instead of using the open API, now we can do this, right? So we can go, hey, here's my Postman config and here's the file path to my Postman collection, which is actually right there in my repository as well. So now the StackHawk scanner can ingest that Postman collection, understand what's going on with the API, and then be able to test it. Some other interesting things that are in here, you'll see I've got the failure threshold set to high. And what that means is when I run a Hawk scan test of my application, I want it to alert me if there's a untriaged high issue. We'll see that in a second. And lastly, we've got this tenant check. So this is my custom test script. And I wrote this test to be able to look for tenant script or tenant filtering issues. There we go. Words are working for me. And basically what that is we set up some of the tests and we say, hey, if we find a tenant ID of 1, 2, 3, 4, 5, 6, 7, 8, if you remember, we were looking at this thing with the users, where to go? Users, search, yes, here. The tenant IDs are 1, 2, 3, 4, 5, 6 in our test script. If I log in with that application user that I have set in the StackHawk YAML, right? This user, and I get to a spot where I find a tenant ID of 1, 2, 3, 4, 5, 6, 7, 8, I want to throw an alert. So now I've integrated in this particular configuration file here, the ability to use Postman collection and the ability to run this custom test script. To run this StackHawk scan, it's just a simple Hawk scan And then we pointed at the configuration file, and this one is StackHawk auth JSON, like this. So that's going to kick off. And the very first thing it's going to do, authenticate to the StackHawk platform, give us a link to our scan, and then it's going to run Newman to run through the Postman collection. So what you'll see start up here is Newman ingesting that Postman collection, running through all of its tests. There it goes. Trying to iterate through the API so that StackHawk Scanner understands it. Now the StackHawk Scanner is actually testing the API, and this link over here, right there, can take us over to the StackHawk platform, which I will just go visit, and we'll see a ton of interesting stuff here. First of all is paths. So the paths that the StackHawk Scanner discovered were informed by that Postman collection. So you can see all the interesting things that we found throughout the StackHawk or throughout the API because of what the scanner is doing, because of what the Postman collection is doing. The other thing that we can see is all of the live tests that are running now with that active scan. So I can see all the tests that are running, how many tests, how long they're taking, all of the good stuff that we're testing with this application. You're going to see that the StackHawk Scanner is going to skip some of these tests. And that's because we've told the StackHawk platform what technology we use to build this application. Lots of scanners out there go, I don't know what you're using because I'm not talking to the dev teams. This thing's already in production. I'm going to test for everything. If you can tell the scanner what technology you built the application out of, so there's one that got skipped. And down here, we're going to skip a ton in this SQL injection section because we only use PostgreSQL. Instead of testing for everything, make the scan time shorter and false positiving on tests for MS SQL or Oracle or MySQL or whatever SQL databases we are not using. We're skipping all of that tests, make the scans faster, make the scans more accurate so that we can correctly identify a bunch of the problems in here. So you see, we're starting to find some issues already. So we got findings in here. Scan's not done, right? Scan's still running. Oh, scan is now done. That's pretty quick. And you'll see that we actually have some information to pop up. So because of that failure threshold that we've set to high, we get an alert in our IDE. So over threshold error, 2 findings with severity greater or equal to high. Not only does this help alert my development team, hey, there's something that we agreed upon that you got to take care of, but it also can be used to break CI/CD builds. So you'll see we got a ScottyCo Brewing custom tenant check. That's the tenant check that I wrote. And then we also have a SQL injection error. By the way, ScottyCo Brewing is a proud sponsor of all the Oktoberfests at my house. Anyway, so we've got our 2 alerts in here. One is that SQL injection. Let's look at that one first. All of this information is organized to help developers go from what? There's a problem to, oh, okay, I'm going to fix this problem. So what is the remediation going to look like? Give me some information. This is written in Spring. Wow, sweet. I've got an article here about how to prevent SQL injection in Spring and what the wrong way looks like and what the right way looks like. That's handy. What is the path that I found this problem on? What method did I find the problem on? What request did StackHawk make to the application? So in this case, it looks like we searched for a tick. And how did the application respond? Well, that seems not good. Okay, so how can I recreate that same kind of test? Well, that's what this validate command is all about, being able to recreate this in a curl, take this information and turn it into a regression test. Lots of different options here, but the important part is how can I recreate this problem so that I can find it and then go fix it and validate that I fixed it. So this one's actually pretty easy. On the items search path, if we search for a tick, it throws an error. So let's go do that. Let's go over here to our items search and not that one, this one, and we will search for that. Hey, look at that. I recreated the same problem that the StackHawk scanner did in my Postman collection. So now, you know, I've got lots of good information to be able to start digging into my code. There's one more that I want to show you, and that's the SAST integrations that we launched. So this one is showing you GitHub CodeQL. The other one is Sneak's code product. Both of those SAST tools are looking at this same kind of code base and can tell us stuff like, hey, we also found a SQL injection on the search service Java file on line 40. So in my IDE now I can go, all right, search service, it's under here under controllers. Nope, services. There we go. Search service on line 40. That's right where my query gets executed. Oh, I just saw this exact example in a blog post. That's not the right way to do this. So now I'm quickly going from how do I recreate this problem? Where does it live? How can I retest it to sweet. Now I know how to fix it and I am fixing it and can retest it again, right? So we could fix this if we wanted to right here in this code. This is how you fix it. That's all up on the GitHub repo if you want to mess around with that. The other one is that custom test. So let's go look at the custom test. We've got the Scotty Co Brewing custom tenant check test. And because I'm creating this alert, I have control of a lot of this text and a lot of the context of what's going on here, right? So a Scotty Co user was able to obtain information about another user it should not have been able to. Please see internal wiki about Scotty Co tenancy checks at example.com/wiki/sSDLC/tenancy. Again, we're pointing out the path and the method, as well as the evidence here and the response. So down here, I've got 1, 2, 3, 4, 5, 6, 7, 8 tenant IDs versus 1, 2, 3, 4, 5, 6, 7. There's a problem there. I also control most of what's going on here. So if you run into problems is a plural of problem, then you reach out to the security team on AppSec help, and we'll help you instantly. So being able to, as an AppSec team, help inform development teams about problems that you know about in the code or problems that used to exist in the code so that they don't pop up again, and help direct them to resources that can help them fix it that are very company specific, right? If we have a library that does tenancy checks, here's how you implement it and make sure that it works the right way. If you run into problems, here's a Slack channel to come ask questions. Now you can write all that custom check. So that's those two things. That is custom scan discovery with, what am I talking about here? Postman collections. There we go. Custom scan discovery with Postman collections and custom tenancy checks. Custom checks. This one just happens to be a tenancy check. The last one I want to show you is custom parameters. So I'm going to kick off a scan here and then go through this configuration file. So custom parameters. This is the same application, same configuration. I changed the name of the environment because I want to keep those scans separate. And this time we're using the Open API spec. But what we've done is turned on the Faker library. So instead of trying to make the StackHawk scanner guess at all this data, we turn on the Faker library and use it to generate valid looking data. So in your API spec, you have a thing that says this field username is formatted as an email. Faker will be able to figure that out and just generate valid emails for you. The other part of this is you have the ability to put in real data. So this is the real pants part, right? So if I see a field that says text, I want you to use pants and I want you to use hosen because those are values we actually use in our application. And if you see a thing that says search text, I want you to use the word best. These are real things that we use in our API and will really drive API as far down as you can get into it. So you can see it's already started to use some of that information, right? So we've searched for hosen in this summary information. If we flip over here to our scan on custom parameters, you'll see the paths that it discovered are, we're using hosen for our search. We're using pants for a search. We are using, down here somewhere it says best. Oh, where'd it go? Somewhere in there, it says best. But what's happening now is because we're using that valid data, we're actually driving the API to get real results. So use the Faker library to generate data that looks correct. So in this particular username one, we say, hey, Faker library, make me an email. It's going to make a real email address, not a real usable email address, but a real well-formatted email address. Some of these other fields, I want to tell it what values to use. And then the last part of it is, if there's anything else that happens in here, Faker will try to make something up for us. So I've specified which ones I want to use for some specific fields. I've told Faker for this particular field, use an email address, make one up. And then for other fields that have definitions, Faker will just make up information in the format that you have specified, if it is specified in the Open API spec. The rest of that is the same. How do I log in? How do I have a failure threshold? What am I doing with the spider? All that good stuff. This scan actually takes a little longer. So check this out. This is kind of cool. When we look at the plugin summary, see how many more tests we're running? We're running more tests, and check, here we go. I'll go show you this other one where we didn't have that custom data on. We're running about 40 tests. Now we have this custom data part on in this one, and we're running a lot more tests. And that's because we're actively driving the API. We're making the API do things it's supposed to do. Therefore, we can do more testing. This is how deeper REST scanning is working with custom data. Much more complete coverage on the test. Still pretty fast testing because the scanner is running on my laptop right here. So the application and the scanner are right next to each other. The round trip times for requests are really fast. We're ripping through all these tests to try to find any problems that we have. And we're starting to get findings. We found that same SQL injection again with the search text of the tick, same response. Okay, so we got the same problem here. And the other thing we can do is over here, we could say, hey, you know what? This is a false positive. And now as a security team, I can, in my application dashboard, I can look at stuff like Java Spring Bolny and say, hey, I'm curious about clicking this button. Oh, come on. Live demos. You know what I mean? Live demos. There we go. So I'm looking at custom tests and I see someone's marked something as false positive, or I see over here, we've got risk accepted, a lot of risk accepted in a different environment. I could go look at this really easily, right? I could go view my latest scan results and go, all right, somebody risk accepted this proxy disclosure thing. Who was it? In our activity tab, I can see that Scott did this. So now I can go have a conversation with Scott. If I think this is a thing that should be fixed, it's going to be really weird because we're going to speak in the third person the entire time, talking to myself. And then I can reset this. I can go, no, we should fix this. So let's make a Jira ticket out of this and send it over to Jira so that we can fix this later on. Or I can clear this status, right? I can say, no, I want this to actually send people alerts. Right? So now, once again, if I've got my failure threshold set to meeting that URL, will trigger that same alert once again. So the ability for application security teams and development teams to interact on these things, to get better collaboration on security problems, get more targeted information about what I need to teach, who I need to teach, who I need to be spending time helping, and finding this information way over here in my IDE. Way before I commit any code, way before I roll out to production, test it while I'm building it. Now, this looks like a lot of information, but if you get past this initial information and test it with each iteration, you're only going to find new stuff, right? The StackHawk platform remembers what you did with that triage information. And if it triggers a new alert, it's probably in new code you wrote or new code you imported. So it really helps development teams go, the thing that I just did introduced a new problem. That makes the scope of where do I got to go find and fix that problem much, much smaller, and is more helpful to help them go fast. Lauren, I think I got everything. Remind me if I missed something.
I think you got it. I think one other point to note was, I think between the two scans, with or without the custom test data, it was like double the paths too. So that was a cool thing. So we have 43 paths.
That's
I
right.
think the other one was like 20 something paths. So really ensuring that you're hitting every nook and cranny and corner and all those good analogies of your API.
Awesome. I'm going to stop sharing. Let's go answer some questions.
All right.
So I know we had
Well,
one question. Oh, sorry. Go ahead, Nicole.
oh no, I was just gonna jump in, but I saw you were gonna answer that one. So take it away, Lauren.
Yeah, so we had one question about SonarQube's SAST integration on the roadmap. So right now we do have Sneak Code and GitHub Code QL. We're looking at some other SaaS integrations, kind of testing the market for them. So SonarCube is one that we get a lot of questions about. No promises yet, but it's certainly one that we are eyeing. So if you have that, it would be, we'll keep that in mind.
All right, one more question just came in. Do you have an example you can show of how the Cypress integration works?
Yeah. I don't have a like working example, but if you go to docs.stackhawk.com and you go to custom scan discovery section in HawkScan, you can see how, let's see. I'm finding it here. Postman Cypress. Here, I can screen share.
Okay. Perfect.
There is the documentation for how Cypress works. So basically what you're doing is just running Cypress with HawkScan. So all of this today is limited to the HawkScan CLI, not the Docker container. So HawkScan CLI, but what's basically happening is HawkScan will run Cypress and then your Cypress spec through HawkScan and understand what's going on with the application so that it can understand how to then go test the application. So out here on docs.stackhawk.com, under the HawkScan section in scan discovery, way down at the bottom, you'll see Cypress. And that is a really good example of how to integrate your Cypress spec into the HawkScan testing mechanism. It's good questions. What are the questions?
We have
We
some
got-
questions in the chat.
Yeah. Okay, so I'll take that first one. I'd love to get a one-on-one walkthrough. How do I schedule it? So there will be a follow-up after this with multiple ways to reach out, but one of them will be a one-to-one salesperson. So that would be a great opportunity to just grab that link and set something up with them. Otherwise, you can always go to our website and there's a requested demo down at the bottom, and that will also hook you up with a one-to-one walkthrough that you can go through. So the next question is, how do you manage FPs? Any work done to reduce FPs?
Yeah, we showed that a little bit. So over on the StackHawk platform, if you're looking at something like proxy disclosure and you think that this is a false positive, you can go, all right, let's just mark all of these things as a false positive. Right, so boom, now I've marked all of those findings as a false positive. The StackHawk platform remembers that. So over here, we've got all of our proxy disclosures as false positive. The next time I run a scan, every time it finds this path and this method in this application and this environment, it will know that this is a false positive and will stop trying to alert people, right? So it's, you can see up here, we've already moved a bunch of these medium issues that were in false positive or in proxy disclosure. Now they're over here in false positive. So again, we're trying to grab your attention for where you need it and not grab your attention for where you don't. And that same information gets populated over here. So let's see, proxy disclosure right here. If we ran that scan again right now, you would see these things would say risk accepted. The scanner remembers that and keeps track of it scan after scan after scan after scan. So again, we're trying to pull developer attention when we need to pull it. And when we don't need to pull it, let them get back to their work of building features and functionality and value for the company.
Yeah.
The other thing that happens there because of the SaaS platform is when people mark stuff as false positive, we use that information to make the platform and the tests better. So if somebody's marking a plugin just generally as false positive, we have turned some of those plugins off. If they're not valuable, they're not valuable. Reduce the amount of time that it takes to do a scan, reduce the false positive nature of what comes out of a scan. If they are false positive and fixable, we usually fix those things or try to get some of that information to make them better. so that the information you're getting out of here is valuable. Good question.
Yeah, we also contribute back to ZAP when we can to help reduce false positives coming out of some of those scans. So like what Scott was saying, if we can fix them, we fix them. One next question, any other ticketing system integrations on the roadmap? For example, Azure DevOps. So we do support Jira and Defect Dojo currently for ticketing systems. We do have Azure DevOps on the roadmap. So that should be coming out into Q4 or early next year. We should be launching Azure DevOps integration. So great question there.
Yeah, the other part of that is if you have an integration that you would like that has the ability to consume API or webhook. We also have those two things enabled for customers is webhook. So we can send a generic webhook about scan results to an endpoint that you build. We also have open API access to scan results so that you can query the StackHawk platform, pull scan results out and stick them in ticketing systems or risk management systems or what other 900 things you might be using to manage vulnerabilities across your organization. Wherever you need to put that, webhooks and API access are both available if your ticketing system is not there today.
Yeah, and we also have different reports available from the individual scan to scan summary reports if you need to share otherwise outside of ticketing systems.
We had
Salesforce or SAP SaaS. Sorry, Nicole, I keep jumping in.
You're good. You're fine.
Currently we are compatible with Sneak Code and GitHub Code QL SAST.
One, I don't think we answered this one in the chat. Oops. From the UI, how do you enable an integration with other platforms except Jira? Scott?
Yeah, same deal. It's either the webhook or some of the other stuff. So Defect Dojo is out here. It's kind of drive through with Sneak Code and GitHub and Slack. Defect Dojo, Jira, Data Center, Jira Cloud are pretty easy. The webhook is super easy. It's a webhook. I use it for webhooks. Anyway, being able to configure a webhook, you just point it at your endpoint and give it some headers if you want to authenticate it, which I highly recommend you do. And then post scan information to the webhook endpoint. You process that data and you can push it out to what other endpoints you need to be able to push it out to. So that's all in this integrations tab on the platform here.
Sweet. And then one more question just around getting like a complete end-to-end product walkthrough and what it takes to get there. So like I said earlier, there will be outreach after this, but also anytime you can hop over to the StackHawk website, stackhawk.com, request a demo, and that's what you'll get. Those demos are, when you request a demo, that'll be a one-to-one. We'll ask you some questions, get an idea of, what you're working with, and then, personalize that demo to what would, fit to what you're looking to do and what the value StackHawk can add. So again, request a demo, but you will get follow-up from somebody after this. And so that would probably be the easiest way to start that process. Any other questions? Last call.
No questions. I can't ship Scotty Co beer to out-of-state participants, so sorry, I'll just preempt that question.
That was my question.
Yeah,
so.
sorry.
Dang. All right, well, thank you everyone for joining us today for the Deeper API Security Test Coverage webinar. We had a lot of fun with the Oktoberfest theme, and we hope you did too. So thanks, guys. Oh, wait. Oh, how do I get a awkward tea? You can, if you find us at KubeCon in Detroit in October, we will be there with all kinds of t-shirts. We have other great t-shirts as well. And we will also be at AWS reInvent in November. So those are the best ways to get a t-shirt. Also, if you talk to us, book a demo, there could be some opportunity for a select t-shirt as well.
We need Hawkward pants.
Oh, yeah.
Real quick,
Love the idea.
there's a question about the vulnerable app details in the chat towards the top. Nicole posted the link. So if you want to go play with that same code we were playing with today in the demo, the link is at the top of the chat. So go grab that real quick. If you want some more information about custom code details, custom variables, custom, any of that stuff, that's all out on docs.stackhawk.com. And if you need help with it, happy to help with our support channel or in your one-on-one demo of the platform. By the way, you almost got a complete one-on-one demo of the platform today.
Yeah.
All right. Thanks, everybody.
Thanks, everyone. Have a great day.
Prost.
Prost. See ya.
There you go. Thanks, everyone. Thanks, Lauren. Thanks, Nicole.
Thanks,
Thanks, guys.
guys. Thanks, Nicole. Bye.
Bye.